All right, what we're going to do on this slide is setting up our substitutions for integrals so that we can understand what's going on. We're going to look at some different things here because at some point in time we're going to have to work with the chain rule. And remember when we took derivative with chain rule, there was a lot of stuff going on, okay? And so this example then just kind of sets our ground rules for that. So we're going to let f of x equals x squared plus 1. We're going to let u equal x squared. So find each of the following. Now, first step, when we take this integral, we need to make sure that all of the variables are the same. So f of x dx, that's good. F of x dx is good. That means that we're ready to integrate. So we go ahead and do that. And we're going to add 1 to the 3, and we're going to divide by that new number. Okay? So as long as I've got x cubed and a dx at the end, life is nice. All right? So here we go. X to the 4th over 4 plus x. And then plus c, because we want to account for all the different possibilities that our constant could be represented with right there. Okay, next up is f of u du, all right? And so what does that mean? Well, we just substitute in our u now. So we're looking at the integral of u du. And that's all that we know at this point in time, okay? And what does that mean? Well, u goes in for that x in f of x. So it's going to end up being u cubed plus 1 du because it says, okay, that we're looking at this function of u. The only function we have is x cubed plus 1. Now, again, the u's match. So since u cubed and it's du at the end, I can go ahead and integrate. This isn't a problem. And I just follow all the integration rules from that slide we just saw. So in this case, I'm going to add 1 to the exponent, divide by the new exponent. So it's going to be u to the 4th plus 4 over u plus u plus c. All right? So these first two guys are identical. The only thing different is the variable on the inside. That's it. But if you look at this last guy over here, this says f of u dx. All right? Those variables are not the same. And so what is it that we're looking at specifically? Well, we're looking at u cubed plus 1 times dx. But I can't integrate this. In order to integrate this, I have to have the u and the x be the same exact variable. That's the only way to get around that problem. Well, lucky for us, we have an equality statement for u, and that is that u is equal to x squared. So right there, I'm going to let u be equal to x squared. So everywhere I see u, I put an x squared in its place, and that gives me my substitution. My integral then becomes x squared cubed plus 1 dx. And now I've got everything together to integrate because the variables are all the same. So the function I'm going to be working on is x to the 6th plus 1 dx. And I follow, when I integrate this, I do everything that I've done in the past. I don't make any big changes at all. The x's are there, x to the 6th dx. So I add 1 to the exponent, divide by that new number, which is going to give me x to the 7th over 7, plus x plus c. And that's all there is to it. Now, it looks really weird. You may have to watch this a couple times, but it really isn't a bad thing. And it allows us to handle the chain rule, which is really important because a lot of those derivatives and integrals that we look at have the chain rule included in them in some way.